So to introduce what we're going to talk about today, you can see on your screen now the three sections of today's session. So a very quick introduction, that will just be a few minutes. We'll then spend the bulk of the time focusing on the research from our recent report, and then we'll have some time at the end for discussion. We very much hope to have questions as we go as well, and to make this as much of a discussion as we can rather than just a presentation. So moving on to the next slide. There we are, the software's working. Just to introduce the three of us. So as I said, my name's John Slow. I'm a director here at Delta and work across our different research services, including a big focus on heat. I have with me Felicity and Jaren.
Hello.
Hi there.
So Felicity is the product manager for our electrification of heat service, and Jaren's joined us recently, but with a long background in heat pumps, heating, and energy services to lead our business development work, particularly around heat. Now, in terms of interactions today, you can ask us questions using the questions feature on the sidebar of which you should see on your screens. You can ask questions just to us. You can also use a chat feature if you like. And we do have you all on mute at the moment. Normally on our webinars, we keep it that way to reduce background noise, which we find can be a problem if everyone is unmuted. We are happy on this webinar, though, because it's a subscriber webinar rather than a public webinar, to unmute you if you have a particular question. So we'll play that a bit by ear. You can use the questions box if you're more comfortable doing that, or using the questions box, you can send us a note if you'd like to ask your question, and we can unmute you so that you can ask your question. Mm-hmm. And a quick refresh on the research that we're talking about. So this slide shows the different services that Delta provides. You can see the top 2/3 of this is our subscription research and our multi-client studies. And the report we're talking about today is covered by the electrification of heat service. It's also pulling on some research we've done on the connected home service, storage and flexibility, looking at the interface between flexible electric demand or generation and the wider electricity system. So I'll hand over now to Felicity, and Felicity, Jaren and myself will all be talking in different parts and making comments, interjecting. And just a reminder, please do use the question box. Please ask us questions. We may not have time to get to everyone's question, but we'll try our best to talk around your questions, answer them as we go through the webinar.
Yes, and if we don't get to your question, we'll get back to you afterwards as well, as we can see who said what after the webinar. So, smart electrically driven heating. Why did we do this report? This is the first in-depth report of our transition from the heat pump research service to the electrification of heat research service. And so it's a very timely report to explore that intersection between electricity and heat. This is a relatively long report, and we're trialing these webinars as a way to help our subscribers digest our research more easily. And so I welcome any feedback that you have on this format afterwards, of course. This research was carried out through extensive primary discussions with industry experts and desk research carried out by the EHS team. And as John said, we collaborated on some of the content with other research services across Delta. A very high-level public view on the overall research that we've done across Delta in this area was presented a couple of weeks ago in our home energy management webinar, Science Fiction or a Golden Opportunity. Some of you will have attended that already, but if you want to listen to that, it's at this link at the bottom of the page, which you'll be able to click on when we send out the slides later. So this report covered three main areas. First of all, what is happening in this smart electrically driven heating space now? what value and technology enablers exist in this market, and where do we see this market going. We also produced a start of our case study library looking at developments in the interface between heat and electricity. This was to complement this report, but we will be building on this as we go on in the next few months as well.
So thanks for our first question. Do we get the slides? And yes, we will send the slides and a link to the recording around to all participants. And remember that as subscribers, you also have access to the full report.
Yes, of course. Okay, so there's a few key findings of the report that I'd like to highlight before we get started going into it in a bit more depth. Firstly, our research tells us that the value of flexible electrically driven heating is starting to be unlocked across Europe. And this provides important value to the electricity system and households as well. We have a substantial installed base of electrically driven heating, which will increasingly become more valuable to this market as we are able to access it in a smart way. And we're already seeing a number of first movers active in this market today, despite its currently small size. We estimate a market today of around 25,000 installs a year, be that retrofit installs of smart controls or installations of new systems, new heating systems which have smart capability. So our key insight from this report are firstly that industries and sectors need to work together to grab the opportunities that smart electrically driven heating provide. And we have the technology to take advantage of this opportunity, but there are currently a lot of different options in communications, for example, to produce a coherent wider system. So that's one barrier that we see. Other barriers to growth in this market are availability of dynamic time of use tariffs and how open the electricity system ancillary services market is. So we'll go on to explore these topics, but these are our key findings from the report overall.
So the market on the left, the market size that you see on the right of the slide looks reasonably small today. We are positioning our research at Delta as a transition from old energy to new energy. And one thing that we're very sure about is that in 5 to 10 years, this will be much bigger. Yeah. There's a huge amount of interest, and I don't think that's exaggerating, at incorporating the demand side and demand side flexibility into electricity markets. Mm-hmm. So what we're seeing today is the early stages, the beginning of that. What we'll see in the long term is electric heating playing a big role in electricity markets. Mm-hmm. And what we'll see in the next years is that transition starting to gather pace.
Exactly. We're going to go on to a market forecast for this smart electrically driven heating market in the next few slides. So on to the next section, our findings from our research.
We've got another question, so thanks for the next question. How do we define smart? Do we mean connected controls?
Well, that's very timely because that's my next slide. It would be, if we define smart as just connected controls, as just the option to control your heating via an app or a program, we'd have a much larger market, of course. And that's something that our Connected Homes service looks at in more detail. We have, for this purposes of this report, we've defined the smart uses of electrically driven heating in 3 different sections. More intelligent use of automation, of interaction with different price signals, for example. And we have 3 main sections. First of all, optimization of the self-consumption of PV through interaction with electrically driven heating systems. This has been especially with domestic hot water systems. Secondly, the efficient use of electrically driven heating to react to hourly dynamic pricing. And thirdly, the use of electrically driven heating to provide flexibility to the grid through provision of ancillary services. There can, of course, be some overlap between these 3, but these were the 3 areas that we estimate in our estimated current European market size. So we estimate, as I said, this annual market of 24,000 installed systems. The 3 categories are here as well. We go into more detail in our report. We're going to put the relevant report slides on the bottom of every slide that we look at to help signpost you through the report as we go. But our first approximately half of the market that we see at the moment is through optimization of self-consumption of PV. This is an increasingly standard capability, especially with domestic hot water heat pump systems, and we can see tens of companies offering this across Europe. Secondly, we're seeing some movement in hourly dynamic pricing offerings. This is very much limited by the availability of pricing structures, etc. But we're seeing movement in Finland, and we'll go into this in more detail later as well. And the remainder and majority of this market is currently made up of ancillary service offerings. We're seeing a lot of movement here in Switzerland and France, and a lot of players eager to enter this market.
So we're aware we've got quite a broad readership in our electrification of heat service, and people from the electricity industry who may know ancillary services inside out, and people from the heating industry who it might be a newer term to. We'll be talking a bit more about each of these three values, but in summary, ancillary services are the balancing services that electricity system operators use to balance the electricity system in real time. So it might include, for example, asking companies with 5 minutes notice to turn demand or generation up or down to make sure the electricity system is in balance.
And we have, I believe, 3 case studies coming up in our future section, How Ready is a Technology, where we'll discuss in further detail a couple of those companies, both in Switzerland and France, that we've identified through our research.
Yeah, of course. We very carefully used a broad definition of ancillary services in this study to allow us to encompass all of the different business models that we see on the market. So as John said, this is a small market. There's a huge amount of electrically driven heating in Europe. We estimate a base of around 30 million heating systems across Europe. Electrically driven heating systems, be that heat pumps, direct electric heating, storage heating, etc. So this 25,000 is a very small part of this at the moment. But if we can access all of this installed base, we have the possibility of accessing flexible capacity of up to 90 gigawatts. So it's definitely a huge opportunity. So why are people interested in this area? We had a look at the potential values available per household to the end user and to different energy market stakeholders for a very much ideal situation. We've got some details of the methodology in our report, but I'm just going to run through the main findings that we had. So first values that we see are values that are very much on the end of the end user, be that through maximizing the self-consumption of PV, minimizing bills, using time of use tariffs, etc. These are values that are more in the savings rather than revenue, but revenue is available to the energy market stakeholder through provision of the services that are needed to help the end user access these values.
So the key point here is that the price signal goes directly to the end user. So the end user might want to self-consume more photovoltaic electricity rather than exporting it, because they don't get paid much for exporting it. Or they might have different hourly prices, and it makes sense to shift their electric heating to hours when the prices are cheap rather than when prices are expensive.
Yes. And smart electrically driven heating enables them to do this. Our second area of values that we see is where the price signal is available to the electricity market player directly, allowing them to optimize trading positions, to access the revenue that for the ancillary services that we've talked about already. Some of this might come through to the end user in terms of an energy provider offering a lower tariff in return for the opportunity for them to optimize their heating. And there also is the opportunity for the energy market stakeholder to share some of the ancillary services revenue with the end user. Not something that we're seeing much at the moment, but it's a possibility for the future.
And the important point here being that, as you see written, the price signal is not visible for the end user. So the end user or intelligence inside the heat pump or electric heating will find it hard to access these values, because you can only access them if you're a player in the electricity market.
Okay. And our third and more unquantifiable value area is here in the indirect and soft factors, where that could be improved end user comfort, or increased customer loyalty to a particular provider, or maximized environmental efficiency, for example. So there's a huge amount of value available here. We use the information available in the market to estimate the potential savings and revenue for each of these players for a year with this particular household. Again, this is a very idealized situation where all of the values were available to our ideal house. In likelihood, it would be perhaps one or two rather than all of them at once. But we estimated annual savings and values to the end user of around 150 to maximized 500 euros, and annual service fees and demand-side response revenue to the energy market stakeholder for our ideal house of approximately 240 to over 1,000 euros per year. Much of the higher end of these values are enabled by access to energy storage. That's very much what is needed in order to access these higher end values.
The other key determinant of value, of course, is the country that you're in. So in somewhere like Germany, there's a lot of value to self-consume photovoltaic electricity rather than export it. Whereas if you're in the Netherlands, they have net metering for photovoltaics, so there's no value to self-consume photovoltaics. So yeah, it's hard to give definitive numbers in terms of the value. What we're indicating here is some of the range that is possible. In general, we think the value will only increase rather than decrease in the future.
Yes, as markets open up and this technology becomes more common. So how accessible are these values? And this is where we got into more of a sticking point, focusing on each value, each application of smart electrically driven heating at one time. When thinking about smart self-consumption of PV in conjunction with heating, we had to consider three main questions. Is self-consumption allowed or even encouraged in a particular country? Is there a feed-in tariff, and how does that feed-in tariff compare to the grid electricity price? We were able to generate this map of the relative values of self-consumption from solar PV compared to feeding into the grid. And as John has already mentioned, Germany, a very highly attractive market for self-consumption of PV compared to other markets, and of course has a high installed base of PV systems as well. So very interesting there. Another example on the other end of the scale is perhaps Spain, where there's currently a tax on self-generation from PV and a requirement to donate any excess energy to the grid. While this tax is expected to be removed in the future, it's very much an unattractive market for self-consumption from PV in Spain at the moment. So having looked at this, and we're able to estimate that approximately 150,000 domestic hot water heat pumps are sold in Europe for use with PV every year. So just looking at the heat pump side of things, there's definitely a market here for this kind of value. But as we said, smart self-consumption of PV requires a business case for self-consumption over feeding into the grid, and that's something that varies country to country. But offerings which provide smart control solutions to the customer can make this an attractive proposition for all of the PV customers across Europe, of which we estimate there are around 5 million customers with PV installations. So as I said, this is very much a value to the customer. Our second application is through dynamic time of use tariffs. And this requires a step beyond manual reactions to a price signal directly to the customer to automatic reactions. Our questions here were, is there enough data on consumption available? Is the energy provider and the energy markets using that data to consider actual load profiles rather than standard load profiles? And is advanced dynamic tariff pricing information available? So thinking about the data, we've got a graph here of the level of smart meter rollout across the EU at the moment. You can see that some countries haven't started and other countries are pushing up to 100%, with Finland being the most one of the most advanced countries in this area at 100% smart meter penetration.
And of course, if you can't measure the hourly consumption of electricity, then you can't bill on it.
Yeah.
So for hourly time of use tariffs, smart meters are a must-have. There are some workarounds possible, but I think really to roll out and see large take-up of dynamic electric heating on the back of time of use tariffs, you'll need smart meters. This is changing, so in 3 years' time, these percentages will look different.
Mm-hmm.
UK will have shot up by a few tens of percents, maybe towards 50%.
Yeah.
So we will see this graph look quite different over the next years.
Definitely. And the second factor that we had to consider is there access to time of use pricing for the customers? And this is our main sticking point. We can see that the only country with true access to time of use pricing at the moment is Finland. And there is emerging access in a few other countries, but Finland stands out as around 15% of domestic customers in Finland are billed based on hourly wholesale prices. This is a demonstration of successful early implementation of an hourly time of use market strategy. And Finland is definitely a forerunner in making use of the smart meter data that we have available. So the value from hourly dynamic tariffs goes to the customer in terms of cost saving, and the energy provider in terms of offering these tariffs and offering particular tariffs that allow them to increase their market share and potentially increase margins as well. Our third application, as we said before, is the value that there is from ancillary services. Some countries are further ahead than others in opening up these markets, and residential use is definitely rare. So we started off by thinking about the ancillary service markets in general. Our questions were, is there flexibility available? Can it be controlled? Is the TSO willing to buy services from the demand side? And is there regulatory support for ancillary services? That allowed us to generate this map, which ranks the accessibility of revenue from these ancillary services in the different countries. And again, some countries are further ahead than others. You can see that the actions of Voltalis in France is a good example of uptake of ancillary services by the French TSO, but prices in this area have been quite low so far. Another example is the UK, where there's a lot of demand-side movement in this area, but definitely not really in the residential markets. So markets are opening up, but it's definitely an area of interest for a lot of people. There's a lot of companies working in this space, but residential is yet to be taken up in full.
So yeah, this graph will look very different in a few years' time. So as Felicity said, system operators and in some cases distribution system operators or distribution network operators are getting more and more interested at procuring flexibility from the residential market. So this will become more interesting, and also the value of flexibility will increase in the future as there are more renewables in the grid and therefore more need for balancing in the grid. Yeah. Although maybe there'll be a huge take-up of batteries and there'll be an oversupply of flexibility. Who knows? We've got one question about smart meters. The smart meters being rolled out in the UK, are they able to do hourly dynamic tariffs? Now, the UK ones definitely can do dynamic hourly tariffs, but it's a good point. Not every smart meter is the same. So yeah. Italy rolled out smart meters quite a long time ago. I would say they're semi-smart meters. They can do billing, so they remove any estimated bills. They can transmit information back on actual consumption, and therefore bills are done on actual consumption. But they don't have the same functionality as the smart meters being rolled out in the UK. So a good point. I think any smart meters being rolled out now and in the future will for sure enable dynamic hourly tariffs.
Yeah, definitely different levels of smartness in across the different countries. Another thing that we see with the smart meter side of things is that there are arising customer concerns about data protection, etc. So there's a lot of barriers again to that smart meter rollout, despite the requirements to do it. There's a section in this report on the customer concerns that there might be around smart electrically driven heating, which would potentially be interesting. In terms of this slide with ancillary services, a key stakeholder in this is aggregators. Aggregators are very much the new companies that we see emerging across Europe, trying to grab this value from ancillary services from heating. Aggregators, for those who are unaware, in very simple terms, are potentially forming that link between the TSO and the user of the heating or the electricity system that is being flexed, providing that kind of middle control and providing that grid support for the TSO. So the main value that we see here is to the aggregator, but there are, of course, other emerging business models as well. So I'm going to hand over to Jaron now to talk about how ready technology is to take on this challenge.
Great, and I'll talk for about 5 minutes on just a couple of slides here. I don't want us to get too far behind. But this is one of the slides pulled directly from the report, page 17. And so we asked the question, well, how ready is smart electrically driven technology and heating technology specifically? Through our research, we found that the installed base of this electrically driven heating technology is generally capable of interacting with smart applications, which is good news. But we also found, as Felicity mentioned briefly, about some of the communications protocols that are either competing or proprietary, or also both difficult to connect and retrofit and communicate with some of these heating applications. So we'll talk about that further in one of the other slides coming forward, but we think that today's market does have a lot of the knowledge and skills to help facilitate this rollout, is working and getting the technology to talk to each other. So I mentioned very briefly earlier that we would look at 3 different case studies of what Felicity was characterizing as ancillary services. So from the research, what we've found is that retrofitting some of these smart functions discussed through the report can allow access to a substantial installed base of electrically driven heating systems. Felicity mentioned earlier the number of around 30 million. We're saying that these functions have an opportunity to address or work with up to that number of installed non-smart grid-ready heating systems across Europe. So we wanted to look at some case studies of interesting technologies or models that are starting to interact and solve problems with some of the existing heating stock we have in Europe. So 3 of the case studies, Vitalis was mentioned very briefly before, but we'll start with a UK example, VCharge, for example. In the UK, there's a small but significant number of homes which are heated by electric storage heaters. And these have traditionally run on a specific off-peak tariff overnight, but they were very difficult to control. So VCharge has demonstrated that smart heating controls can be fitted to these existing storage heaters to mark with a smart energy tariff. So that's one example we wanted to illustrate in the UK market. In France, Vitalis has developed a device which can be retrofitted onto direct electric heating systems, which can help monitor and control the operation of the system. The number that Felicity illustrated before, in terms of annual installations, up to about 25,000. We're looking at higher numbers, but that is an aggregate over a number of years. And one of the instances we looked at for controlling and communicating with heat pumps in Switzerland, TICO representing an option to offer a retrofit control solution with the installed base of heat pumps there, providing better end user interaction with the heat pump.
So in the service webpage on our website, you can get access to case studies, and we'll be updating and expanding those over time because there's more and more companies like these three entering the market with flexible offerings. We've got one question about the cost of retrofitting and how much value is shared with the customer.
It's an interesting one. Voltalis, for example, will, I believe, fit their system for free. And in return, the customer allows them to access and control their systems for ancillary services. It's a difficult one. In terms of cost to Voltalis, I'm not particularly sure.
I think we're looking at about, from what I understand, in the sort of 400-500 euros a household range. You've got to have an electrician go in. So that visit alone is expensive. You've got some hardware with some metering requirements, some communications requirements. So it's not cheap to do. Voltalis themselves don't share any of the money they make from the ancillary services back with the customer, but they do share control capabilities and information on how the heating's been used.
So that's an example of those softer values that we included in our value breakdown earlier.
Likewise with Tico, I think they have a similar order of magnitude of cost. They've got to put, again, a specific meter in that the system operator in Switzerland recognizes. And they originally gave the customer a nice Swish remote control heating app to control their heat pump. And that was the value exchange. Tico gets to control the heat pumps and make money from it. The customer gets a nice heating control app. They've actually started charging the customer for that heating control app as well. So I think there's no formula to how you share the value with the customer. There's a lot of experimentation and a lot of learning at the moment. And that's something we're going to keep looking at really closely, because I think getting that balance right between making enough money to sustain the business model and sharing value back to the customer to make it exciting and compelling for them is a really hard balance to get right.
It's definitely why it was difficult to estimate the value that people would get, especially from the ancillary services side, because there's such a range of sources of value within the definition of ancillary services, and also such a range of approaches that companies might have in terms of sharing the value with their with their value chain as well as their customers.
And there's also the question of what value the customer will get in addition to the cost or economic value, as well as the interaction that they have with some of these smarter control systems as well.
Sure.
Okay. Do you want to go to the next slide? Oh, and yes, we showed that earlier as well, just estimated market. Okay, so looking just very briefly at the control requirements required, This slide briefly illustrates how heating units in the home communicate with systems both within and outside the home. And traditionally, we had electric heating units which might have been connected to a local control internally in the home. Now we're seeing that increasingly electric heating units are having the inbuilt controls if they aren't being retrofitted. And controls need to interact through a common protocol to interface with the end user and app they might be using, or to interface with a utility as well. And the next slide just will illustrate briefly that there isn't a common approach that we're seeing in the market at present. And we've identified that this could be a problem with helping the market grow maybe more quickly, or having consumers or even members of the utility, for example, taking full advantage of connectivity options and features within new products that are coming out.
Just to explain this diagram a little bit, this is one of the annexes in the report, and we took a cross-section of the different types of companies there on the market, as well as different types of communication protocols. And we found that the orange background shows that a particular company is a member of the association promoting this particular type of communication protocol. And the stars on the boxes show that they also have products which either have inbuilt capability for this particular protocol, or they sell a gateway which allows them to convert those protocols to the other ones on this list. So the main takeaway here is that nobody quite knows which product to back, and everybody's trying to make their products as flexible as possible, perhaps to the detriment of cost.
One interesting development from Dimplex, Glen Dimplex, who are one of the leading manufacturers of storage heaters and a big heat pump manufacturer, they have just they're launching a cloud where they will allow others to access their storage heaters. So at the moment, most of the protocols are closed, and manufacturers have kept them quite closed. In Germany, with Smart Grid Ready, there's a degree of standardization and openness, but I think the endpoint will likely be open protocols, and Dimplex are one of the first to take a big step in that direction.
Definitely.
Keeping on time, we want to leave enough time to look forward, so we get very excited about this topic, as you can see.
So very quickly, our market forecast. A difficult one to do, a lot of variables. The one area where we know the most is around the blue section, around smart optimization of PV and domestic hot water systems. But this market overall is niche and will remain so in the short term. We expect a general uptick around 2020 and 2021 as countries, first of all, we hope and we expect that their electricity markets may become a bit more open, but we also know that several feed-in tariff schemes end around 2020, in the early 2020s, and that's when we expect to see an increase in the attractiveness of self-consumption of PV and use of these smart-enabled electrically driven heating systems across Europe.
What makes this hard to do? So we do a lot of forecasts in our work at Delta. Some forecasts we're very, very sure about. Others we can see are much harder because the drivers in the market are much harder to predict. And this is one of the harder forecasts. Predicting the rate at which hourly tariffs will be rolled out, predicting the rate at which system operators will open up their ancillary services markets, is very hard to do. So this is our central view.
A conservative central view. We do have these unknowns that could make this take off a lot faster. As John said, the opening up of these markets, the availability of time of use pricing, etc., rollout of smart meters even. There's a lot of variables and the associated regulation as well with that could enable the rollout of smart electrically driven heatings towards the mainstream much faster.
So this is a sort of forecast where we can be quite sure about the next couple of years. We can be quite sure about 5 to 10 years' time, but the journey between the next couple of years and 5 to 10 years' time is difficult to predict. But if you're in this market or want to be in this market, then it will for sure be a growing market. It's just a question over how exponentially that will grow.
Yes, exactly. So that brings us back round to our main conclusions, which I won't run through in detail in the interest of time, but basically this value is there. There's potential value. There's a lot of players in this area, and the value is starting to be unlocked across Europe. We've got some barriers around the openness of markets and how we can access those values in particular, but we also have to learn how to simplify the ways in which our technologies talk to each other. So here we are, small market, lots of players, lots of interest in it, and we expect growth as well.
Had another question, so thanks for the questions and please keep them coming, as to who is really well placed in this market. And I think it's interesting that the case studies we showed were all from companies that are not an energy company and not a heating manufacturer or not a product company.
We do have one of them in our case studies, though.
Yeah, so there are a range of different companies active here. To pick out an example, NIBA has built intelligence into its heat pumps so that its heat pumps can pick up time of use price signals and determine how they can best operate to keep the customers warm but to run when the prices are low. So there's certainly an opportunity for electric heating product manufacturers, heat pump manufacturers, to access some of this value and to grow their businesses on the back of flexibility.
Definitely.
Energy companies, if we look at who's to support VCharge, it's an energy company, OVO Energy, one of the second-tier energy suppliers in the UK. And they see that they can offer more competitive electricity tariffs if they incorporate flexibility into their business. So there's certainly an opportunity for electricity companies and controls companies as well. So companies, you could argue what VCharge, Tika, Vortalis are doing are effectively operating as a control company that's also an aggregator.
Mm-hmm.
So there's a lot of opportunity here. No one has really staked out a big claim to the space. And we can see the strengths and weaknesses of the different types of companies. And it's going to be fascinating to see who works out how to grasp this opportunity in the next years. And if we can help with discussions, sharing our views on a one-to-one basis, then we're delighted to do that.
Definitely. Any more questions coming in, John?
There's a couple more, but I'm keeping an eye on time, and we always try and finish by when or before when we promised we'd finish. So maybe just to remind everyone that these slides and the recording we'll send out to participants. Look at the full report if you haven't looked at the report. And we know one of the best ways for you to get value out of it is to ask us questions.
Yeah.
So we're meeting a number of you shortly at some of the heat pump events, electric heating events in the next months. And we also have our summits. So you can see here the next heat summit will be in Berlin next June.
Yeah.
But of course, you don't need to wait till then. We'll be talking with you individually.
Definitely.
And please don't hesitate ever to pick up the phone, drop us an email. We like to talk. We're happy to debate. We enjoy challenges. So
and if you like these webinars, let us know, and we'll do more of them. So.
Okay, so thanks very much for your questions. Thanks for your time. I hope it was useful for you. We would appreciate any informal feedback as to what you liked, what we could do better, and we'll be in touch with you all very soon and tell us what you'd like to see in the service. So thank you all very much, and we'll be in touch soon.
Thank you.
Yep, thanks. Have a good day, everyone.
Bye.